So, first thing, before we can do anything else, and we're doing stoichiometry, we have a product. Before we can do anything else, we have to figure out which one of these two reactants. These are the two reactants are on the left side. Products on the right, reactants on the left. We need to find out what a limiting reactant is. To find the limiting reactant, we've got to do a mass-to-mass calculation from both both reactants to the product that we're looking for. And in this case, we're looking for this product, and we know that because this is the solid the question asked about. Okay? So we're going to, each time we do these calculations, we are going to ignore sodium chloride because it's not our product. Don't need it, don't want it. What we want is iron 2 carbonate because in this case, the problem asks for the product that's a solid. If you read the problem, it asks for the product that's a solid. So this is the one we're looking for every time. Okay? So the first thing we got to do is convert. Let's just do the one problem at a time. This is what we learned before spring break. Now we're going to apply it to a larger problem. We did the mass-to-mass problems before spring break. You should be able to do this. Okay? To get from grams of sodium carbonate to the grams of this stuff, I've got to first convert this into moles. And what do I need to do that? What do you do to calculate? What do you have to find to be able to change something from mass to moles? Molar mass. Okay, so we have to find the molar mass for sodium carbonate. And you should be able to do this without me showing you. Okay? So I'm going to let you calculate the mass of sodium carbonate. So, this is how you calculate molar mass. This is the way I've taught you to do it. And I've asked you and I've told you it must be organized in this fashion for me so that I can tell what you're doing and tell where your mistakes are. Okay? Okay, well this is how many places there are on your periodic table for this class. Okay, and you have to get rid of two digits over here because there's empty slots over here. And this is the number you're going to end up with. Now, what we want on the bottom of this fraction we're making here is the side of this equality statement that has the same units and species as what we have on the top here. And that'd be this left side. 105.9884 grams Na2CO3. And on the top is 1 mole. Na2CO3. Deja, did you have a question?
Yes, sir.
What's your question? 989. Where's your periodic table? Right here? Yep. Oh, it should be 12.7 here, not 4. I apologize. Does that change this number? What does it change that number to? That should be a 7 instead of a 4? No? What's it come out to be right here? Do I need to add it again? You haven't added it up yet? You got this number? Oh, I must have plugged it in. I must have plugged it in right. And okay. All right. Now, once we're at this step, then we're ready to cancel units and cancel species. Okay? Yep.
I have one more question.
Okay.
The number you multiply and by, that's the mass and the part.
Here? This number here is the number of those atoms in the formula.
Okay.
All right, now the next step then is the molar ratio step. This is how we get from one species to another. This step right here was how we got from mass to moles. Okay? Now we're going from one species to another. So we want the number of moles from the balanced equation on the bottom. So in the equation up here, there are 3 moles of sodium carbonate that goes in the bottom. And we're trying to find iron 3 carbonate. That goes on the top, and there's only one of those. There's an implied one here. And we can cancel moles. Those are our units. We can cancel the species here.
Does that say Na2CO3? Because it kind of looks like Na3CO3.
Na2CO3. Okay? All right. Now we've got to get from moles of this to mass of this. What do you need to get from moles of a species to the mass of that species? Same thing we did use to get from mass to moles. Molar mass. We've got to calculate the molar mass of iron 3 carbonate. Okay, so we have in iron 3 carbonate, you've got 2 irons. Okay, we have how many carbons? 3 carbons. And how many oxygens? 9 oxygens.
My answers are always going to be wrong because my periodic table math was wrong.
I gave you another periodic table last week, 2 weeks ago. So, I want you to be very careful about using your calculator here, okay? If we added this number to itself, which is what multiplying by 2 means, right? Just add to itself. This 5 would add to another 5, which would give us a 0 or 10. So we have a 0 under the 5, right? So we actually should have a third digit here. Okay? Your calculator won't show that last digit after the decimal place. You have to know that you're going to need that. All right. And so 12.0107 is be 24.0214.
I thought trailing zeros didn't count when you're running.
What now?
I thought trailing zeros didn't count.
Well, this is not a traveling 0. This is a significant 0. Okay, because the 5 is significant. If you add another 5, a 0 that follows underneath that, when you add them together, that 0 is significant. So we have to have that 0 there. Now, I probably would count it wrong if you did it that way on the test, but you need to know that should be a significant 0 there. Yes.
Carbon, I don't know, like, I got different numbers.
Did you?
Yeah, I got 36.0.0321.
Oh, I multiplied by 2, didn't I? You're right. 36 point what? 0.
321.
You're right. Should be a 1 here. You're absolutely right. I don't know why I multiplied it by 2 here. Okay. All right then. Let's add it all up. You should be working ahead of me here so you can practice this stuff.
What's the number 28.323?
Well, I multiplied by 2 for some reason. It should be 36.0321. Just a second.
36.0321?
Yes. Okay. We've got an empty slot right here. in this last place over here. Underline that. Round off. You get 291.717 grams of iron 3 carbonate equals 1 mole of iron 3 carbonate. Okay? If I have moles of iron 3 carbonate on the top here, what do I need on the bottom here?
Moles.
Right, so this side of the equality statement goes here. The other side of the equality statement goes on the top. What? Slide over.
Slow down.
We're going to cancel units and species. Moles cancel. Iron 3 carbonate cancels. Now we're ready to do this math.
Move that down a little bit.
Well, you can do the math for yourself.
No, it's not the math, it's the final product of the last problem.
How about that?
Yeah. How did you get Fe3? I thought it was Fe2.
Well, you're right. I had 2 here, and for some reason I was writing 3 there. I know. But I've got Deja over there to keep me straight. Gracious alive, people. Come on. All right, here we go. Here's the answer. I hope you've done this math already. Okay, we need to move along. And how many significant digits do we need in this answer? Either one, they both get us to the same place. These 2 zeros? No, we're going to keep those. Counting numbers like these don't matter. We look at the measured numbers like this and calculated numbers like these 2 right here. Four significant digits. This is the one with the least digits. That's okay. Look. Hey, she's trying. She's participating. She's an active learner. Don't give her a hard time. All right. Well, let's try not to, okay? All right, so this may be our limiting reactant, or it may not be. We won't know till we calculate this one.